Scale Talk Recording 3 and go. My talk is Linux and its microcomputer predecessors pre-1996, also known as Why Linux. I really value accuracy, so if you find any mistakes, you can go correct me here. I promise to leave this URL live until at least 2034. That's 10 years from now. Let's start with players. I'm not going to read the slide, but I'll give you a few seconds to read it. This is a general talk in case you haven't seen these terms before. Okay, we're going to move on. Chapter 1, the present. We all use Linux, even if we don't know it. Whenever you go see a machine rebooted at a grocery store or an airport, it's like, oh hey, there's that penguin again. Linux has arguably become the most ubiquitous operating system. But how did that happen? Well, one story is often cited. Essentially, a 21-year-old posted to a news group in 1991 about a new operating system he was working on. Everyone came through, and the rest is history. Hold on. The world doesn't work that way. I just do not believe it. That sounds ridiculous. A college kid with a hobby project started a computer revolution by posting? I don't believe you. Even at the time, there were a bunch of free Unix choices that were available. Here's a list of them. GNU OS was in there like 3 times because it was promised a bunch of times but never delivered. There's a bunch of other ones, actually, that you could get on microcomputers at the time. Here's a list. These are only the Unix ones. Oberon by Pascal's progenitor Nicholas Wirth, for instance, is from 1987. And there were other minor ones I found references to in the back of magazines and long forgotten Usenet posts. They didn't even make my slide deck. There's various commercial efforts up here. Some things are left out. Some of these are complete systems. Others are just kernels, such as Mach. The point is, it wasn't Linux shouting out from the wilderness. There was an active and vibrant Unix on the PC ecosystem and underground that predated him substantially, an industry which arguably hasn't had direct lasting impact. Products such as Xenix and Coherent, for instance, were hot stuff, and now only scholars and historians know about them. So that means that this guy was the winner of the Unix war. Because this guy and his pet project won the Unix war not only on microcomputers, but on all classes of computers. I was only able to find one commercial Unix still around, except for the special case of Apple. It's XeneOS UnixWare 7 Definitive 2018, which last release was actually in 2017. It looks like it can still be purchased, and that's it. It's deader than dial-up. People say, hold on. What about that BSD lawsuit? Well, let's get into it. There was one substantial player that still had impact, BSD. It has a history stretching back to the mid-70s. The two relevant BSD names for our story are husband and wife team, Bill and Lynn Gillette. Why didn't this win a theoretical Unix war? Well, this is usually given as the reason. But it doesn't really make sense to me, because was Linux held up by SCO's 5 lawsuits over 13 years? There's this BSD math, and it doesn't add up. I'm not persuaded by it. BSD is much older, and in an interview with Bill Gillette in 1994, he says he started working on 386 BSD when the 386 came out in 1986. Now, if I was ever to teach an operating systems course, I would use a NetBSD kernel. I think it's great. It's a great software. But if we took this at face value, that there was a 2-year hold in BSD, then we should go over to, say, I don't know, Usenet, and see a fair amount of silence during the lawsuit period. So I went over there and looked. But in fact, we do not. This is a small snapshot of activity that covers just 2 days. It was lively and vibrant. Some of the authors had political statements in their SIGs against the lawsuit, but there is no evidence of a chilling effect. The highlighted post in the screenshot above is an update on the lawsuit amidst a bunch of articles talking about progress and bugs. I mapped out the velocity of the 386 BSD Usenet articles and tried to see if there was any noticeable decrease or change in the velocity of activity correlated with the court case activities. And although I'm not a data scientist by any means, the two looked completely unrelated. Lastly, there were a number of articles across Usenet with titles like Linux or 386 BSD, where people listed out comparisons on which one they should choose. Although many included minutiae such as specific hardware and protocols, none had a reference to the lawsuit as a reason to choose. So I have to be forced to reject this hypothesis, as often given, but there is no contemporaneous material evidence to support it. If you want to tell me how wrong I am, again, go to the URL and tear me up. I just want things to be accurate. So regardless, it looks like that Linux has become at least an order of magnitude more prevalent than BSD. Why is that? Well, I present 2 theories up here. The first is a 19th century approach to history called the Great Man Theory. Essentially, I say Isaac Newton and Einstein, and then we have Linus Torvalds. The second is a latter 20th century approach called history from below, or often social history, and it's way complicated. All these charts, we're going to go over them, but not on top of each other. Anyway, let's go over the once in a generation. This one is rooted in social hierarchy, so I don't really like it, but that's not the point I'm going to get into. I just don't find it useful. It says some great and glorious thing happened, but you can't do it because you don't have the right genes or whatever. I just don't like it. So we're going to go with no superheroes required, which is a social history approach. Using the power of syllogisms, we're going to say that mere mortals did this. We are mere mortals, therefore we can do it. So take that, Socrates. Number one is much shorter. There's an 1841 book by Thomas Carlyle titled, literally, On Heroes, Hero Worship and the Heroics of History, positing great men should rule and others should revere them, presenting a Horatio Alger story, and if I did that, this would just be a fawning biopic. However, we have a much harder task ahead of us. We have to start with hypotheses. So, more terms. I'm just going to leave this up for a few seconds for people to go over it. All right. Let's just pretend that you did. All right. So, if the center will not hold, if things fall apart, and mere anarchy is loosed upon the world, we might as well make it productive and get a nice operating system out of it. Maybe a free Unix needed, a hacker and underground culture, increased power of microcomputers, wide availability of the internet, and something that didn't have legal problems with it. Maybe. There's also the maybe not, things that are often presented as reasons. Here's some of them. Unix was thought to be too complicated. Not really. It had been praised for simplicity and elegance. If you're charging $200,000 for the source license, then yes, it's a very complicated and magical thing. And then we talked about community-based programs were thought impossible. Well, not really again. There was an organization called Share that was started in 1955, and they came up with something called a Share operating system in the late 50s, which was a community-based operating system where people would share the source code. This was for the IBM machines. This is out of Los Angeles, so LA Pride, I guess. Let's go on. So the pretext. This is the ancient history. And so let's go to Unix. Although the project started in 1969, the first official Unix paper, if you will, was in 1974. I've extracted 4 principles from it that will be useful for our journey. Leverage, don't invent. Needs, not desires. Doing beats planning. Use early, use often. And although these things maybe aren't the best advice taking independently, the idea is together maybe they can form a synergy so we can get nice products out the door. Maybe. Unix was designed for a class of computers cheaper than mainframes that died out in the 1980s called mini computers. They were about an order of magnitude or 2 cheaper than mainframes and also less capable. Well, at first, people wanted to solve their mainframe tasks on cheaper class hardware, because that might have been all they had access to, were the mini computers, which were still the cost of a luxury car. So people were trying to make expensive things cheap. And so you can see right here, we have mainframes at 10 to the 7th cost, and mini computers, 10 to the 5th, 10 to the 6th. Then we have workstations in the 80s, 10 to the 4th, and then Linux was trying to get microcomputers down to about 1,000, machines you can buy for maybe $1,000. You want compelling features on the more expensive machines than the cheaper ones. Something called Bell's Law. It was from 1972. Roughly every decade, a new lower-priced computer class forms based on a new programming platform, network, and interface, resulting in new usage and the establishment of a new industry. As mini computers came on the market and became more powerful, Unix was there to leverage increasing capabilities of the machine. And as a result, you had to have software reimagined, and new hardware provided the new context. And so this is just here for conceptual. Let's say graphic needs, data processing needs. These various needs grow at a certain rate over time, while the power of the machines grow much faster than that. There are only mentioned examples. The velocity of progress went faster than people's needs. This can be embodied in something called Grosh's law, which held that more from the 60s and 80s, that computer performance increases the square root of the cost. That sounds complicated, but basically the idea is that you pay twice as much and you get 4 times the amount of computing. This was potentially maybe used from IBM to justify the idea that you should always pay more because you're getting more value for your dollar. However, it seems to be somewhat true, but especially if you combine it with the more common Moore's law of the 80s and 90s, that transistors per chip doubles every 18 months, so that you can see how the industry would eventually eat itself through a multi-decade-long digestion. So as when you combine the both together, then you have more powerful computers at cheaper costs over time. However, when new things come in, they come in unpolished. Like Explorers, the people who get there early don't have it easy. And so we have Unix as a hacker's tool. Initially, it was no advertising, no support, no bug fixes, payments in advance, and they were trying to make it to be something that was good for programmers. Basically, you're on your own. Hey, isn't that fun? And that's okay because some of us are crazy and prefer it this way. One of them was Linus Torvalds from October 5th, 1991. You also need to be something of a hacker to set it up. So for those hoping for an alternative to Minix 386, please ignore me. It's currently meant for hackers interested in operating systems and 386s with access to Minix. Maintaining focus is about intentionally ignoring. I wish it was nicer. There's also, because we're dealing with hackers here, we are dealing with an underground. It came in from the bottom up. Not only did Unix own the microcomputer market, but infected everything from workstations to mainframes. Unisys, one of the mainframe makers, had an article on September 7th, 1987, issue of Computer World predicting a tripling of Unix sales over 1 year. Oh, I did that wrong. Because I should make this... Sorry, that's the next slide. Whoops. Because you had to know what you were doing. It was initially introduced through engineering and technical, and not through sales channels, but it worked. And so essentially, you had to have these lower-end programmers that a manager would come in and say, "Oh my God, we have Unix on our machines. Where did this come from?" The programmer was just like, "I don't know. I have no idea. But now I can get stuff done." So anyway, let's go to chapter 4, the problems. So, Unix is a success. It looks like we all won, but not so fast. This is what I was going to say. Unix met people's needs. Not only did Unix own the microcomputer market, but it infected everything from workstations to mainframes. Unisys, one of them, yeah, we already heard that part. But anyway, the whole point here is that you had ruinous desires from all of these different companies, and they wanted to have market differentiators. I should put that thing in. Talk about market differentiators. Okay. I'm still editing things. You know that. Anyway, and we had different organizations that try to get the soup to be more organized. You have Unix International, which is actually AT&T and Sun. Then people are like, "Oh my God, that means that Sun's gonna get a preferential place." And so a bunch of other ones made the Open Software Foundation, which decided to make a microkernel called OSF1, and it was a big mess. And it turned out that it wasn't the bickering amongst them that was the real problem. It was the issue of Microsoft. But anyway, that's when microcomputers met IBM. And the revolution was won, but as Franz Kafka said, every revolution evaporates and leaves behind only the slime of a new bureaucracy. And in 1984, oh yeah, also like mention Microsoft as the real fear. In 1985, Microsoft argued that Xenix would actually be a multi-user version of DOS, and Ballmer in 1987 said they didn't see it competing with their plans for OS2, which at the time was seen as successor to Windows 1.0, publicly, maybe privately, it was Windows 2.0, but I'll be on the down low. In fact, in 1985, Microsoft was quoted as saying there were only over 100,000 Xenix installations. At the time, it required 12 360K floppy disks to install, which was seen as a big burden. Putting that in perspective, in case you're not old, a 32 gigabyte $5 micro SD card is about 93,000 of these floppies, which is about 190 meters stacked end to end. That's like a 2.5 minute walk. All that storage is now the size of your thumbnail and costs a noticeable amount. That's because software distribution used to suck. So, here are some various forms of software distribution, including having to type it out of a magazine back in the day. Speaking of Microsoft, the punch tape up here actually is how they distributed BASIC for the Altair in the 1970s. Paul Allen made a loader as he flew to MITS to demo it by using a hole puncher on the punch tape on the plane. Really, this happened. He had no idea if any of it was going to work, since even the BASIC had been written on an emulator that he and Bill had made by reading some manuals. It took about 20 minutes to load the tape. That's how long software took to load. And when he got there, and of course, when he was done, it wasn't stored on disk because computers didn't have one. So you had to keep the computer on if you want to use the software. And if you reboot, you got to reload the tape in. Software distribution used to suck a lot. So here is different kinds of software distribution. We're going to quote Marketing High Technologies by Bill Davidow in 1986. It's not a product without a distribution channel, or in Linux's case, a distribution. The technology may have the potential to address the needs of many, but without specialist distributors. To put it in the hands of the customers, it will not succeed. Products are sold through distribution and not to the distribution. Here, we're mapping out that from these different kinds of distribution channels, we have retail, mail order, SneakerNet. The accessibility goes up as you go up the graph. And so retail was much easier in the 80s than, let's say, internet, which was really hard to get access to. And so if you're making a million of something, then retail eventually gets cheaper. But since a lot of products are actually in here, actually, I want to modify this chart to say something like mom and pop, which I hate the term, maybe small scale software. And then say, it didn't make sense for the smaller scale software to go to retail because they weren't selling the kind of volume that was needed. Anyway, there's various non-free retail. Let me write that thing down. So with this one, we want to say something like, put in a spiel about the accessibility. That's fine. And maybe modify the chart for volume examples. Okay, so the next one is I have to let the cards on the table. This is going to be the public domain slide, which I was researching today, and it's still not done yet. And so maybe tomorrow I have something better for that. So, blah, 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 public domain. All right. Minix relied on the constants holding from... Okay, now I am starting to expose this. And so if we do public domain first, then the software distribution doesn't make sense. So, but I have to introduce public domain before I get to Minix because this is the one that mentions public domain. So what I could do is these here is a thing that I need to struggle on. Essentially, the word these doesn't. Oh yeah. The word. Jesus Christ, this fucking cable. Word these is now a dangling modifier. So I need to work on that one. This transition doesn't work. Anyway, even if Minix doesn't have these onerous rules, because of the prohibitive logistics around software distribution updates, especially customers initiated, were fairly inconceivable. So here, Andy Tannenbaum said that Minix is not public domain. However, the publisher does not object to people making a limited number of copies. That's SneakerNet. If you want to sell it, you need permission. Well, yeah, this is redistribution based on source modification. In the book, you'll find a postcard that you can use to order the software. That's mail order. I don't want to spend, and then he goes over all of the issues. Here's GNU, same issues. The easiest way to get a copy of GNU software is from someone else who has it. That's SneakerNet again. If you have access to the internet, you can get the latest. Okay, that's internet distribution. Forward-thinking GNU. You can order one. Okay, that's mail order. Consult the company. It cost money. But here, they didn't actually understand the potentials of what internet-based development could unleash. They were still doing these, what's called firm-based. That's what it's called. It's called firm-based software development. So people claim that GNU was a pioneer getting away from that, but there's really no evidence for that. Anyway, they started doing it kind of after the early 90s, 92, 93. So they were kind of, I mean, they hopped on quickly, but yeah, arguably BSD and Linux was there first. Anyway, so they were trying to hire people there. So the issue here was that they were still having issues because of the update, firm-based software development, and then that's how you do the update transition. Okay. So software updates were kind of difficult if you're trying to do something that's a retail-based. In fact, there's a term for this that I found out today. There's a term for the bottom one. So that's what I want to do. So there's a term for internet-based development. I found a Wikipedia page on it, and I want to use what that thing says. I found a whole body of literature that I didn't know existed on open source development or whatever scholarly work about this stuff from the mid 2000s. Anyway, so let's go over the script. So it says, if you want to update Lotus 1, 2, 3 through retail, it means not a chance. So, like, hell no. But depending on the distribution channel, you had more of a chance of you or a forker being able to do updates and modifications to software. So, internet is the best one down here. Linus Torvalds saw this really early. We're going to go back to the same posting they did on October 5th. I've enjoyed doing this, and somebody who might enjoy looking at it and even modifying it for their own needs. Somebody might, yeah. It is still small enough to understand, use, and modify, and I'm looking for it. You know what? I am going to get rid of that. And modify, and I'm looking to, that is all I want to do, actually. I want to get rid of that thing. I'd like to hear from you so I can add it to the system. Just cut that out. He had a little quote there about Minix, but I want to cut that out. So, let's go into the politics. The complexities of building software, and this is about the complexity of building software and not about electing people. So, the first one is software evolution. And you may have heard that commercial software began with Bill Gates' open letter to computer hobbyists in 1976, where he denounced SneakerNet distribution of Altair Basic because he didn't get paid for each of the copies. That's not really where commercial software began. Initially, software was in-house coupled with hardware or contract-based. The shrink-wrap version of retail commercial software, popular in the 1980s, kind of began in 1968 when hardware vendors agreed to decoupling software and birthing the vendor-supplied software catalog. Some references will actually cite United States versus IBM, filed January 17, 1969, as the birth, where government charged that bundled software was anti-competitive. But the case was dropped 13 years later, so that's not really it. It's really this meeting that was held in late 1968 instead. Sorry. So anyway, let's go to Software Revolution 2. The issue with this decoupling is that this allowed these types of forks to happen. So here is Unix timeline in the late 80s. Each of these things is a different kind of Unix. As you can see up here, each of these things is different. You've got different kinds of BSD up there, Plan 9, you have Mach, but you also have commercial stuff up there, Xenix, and each of these actually have different answers to all of these fundamental questions. So that was a problem. And so Linux was able to fix all of that by unifying from below. All the convergent code and correspondences were public. Before social media, there was social software, and he was able to do that over the internet. And so it's very online, and it meant, and because he paired it with GNU copyleft, which is something that should be explained in a public domain site beforehand, there were no legal hassles or confusion. It made things clear and no longer complicated. I was complicated there twice, so I need to get rid of it. And then I've moved it over here. So there's actually one more part of politics I want to talk about, and it's the politics of building software. So beforehand, we were talking about in the 1974 Unix paper, beforehand, when we were talking about we mentioned needs, not desires. Here's where it comes up again. So here, essentially, you have bugs, needs, desires, and aspirations. Each one gets more abstract as you go away from it, and you have these known, agreed, and demonstrable. The easiest development cycle is things that are known, agreed, and demonstrable. And the hardest one is when you are up here in the aspiration space. So let's take an example. Raj Reddy of CMU, who in the early 80s talked about a theoretical 3M computer, which had a megabyte of memory, a megapixel display, million instructions per second, and was under what's called a megapenny, or $10,000. This was seen as what he termed a minimal workstation. But there's no detail of how to get there, and it took a few years. But these days, the lousiest smartphone hits those numbers, but that's 40 years later, or about 1,000 regular sprints using the Agile method. Yeah, using Agile planning. So, you want to stay within needs and bugs. So let's move on to the prices. So first of all, the most obvious price is the price of money. Somebody wants to have a Unix, but 6,700 isn't low price. There's a chart. There's a little thing here, low price workstations from Sun, quoting that thing. However, Intel came out with a nice thing called a 386 processor, which has a lot of workstation-like features at a lower cost. And you could get a machine. This is the same month. Essentially May 16th, 1990, and Byte Magazine, June 1990, which would have been done in May, at about $6.99, so 1/10 the cost. There's a debatably humorous adage about this concerning Andy Grove and Bill Gates. What Andy giveth, Bill taketh away. In this case, new software Linux, and it was consuming the increase in capabilities provided by the 386. But that is not the only kind of price there is. Now, there's also the price of time. Things are free or cheap only if your time is worthless, but maybe not. So I need to put in more stuff about this, about how, yes, describe the fucking chart, Chris. Okay, so I'm just going to wing it again. This is going to be my third winging of it. is that yes, things like Windows were easier to install at first, but but you'd hit something called a capability law as you try to have a problem specificity, and things like you can see the operating system. You had to use all these complicated tools. All of a sudden, it became very, very difficult, and the costs went up enormously. In something like 386 BSD, it was a difficult system to install, but there was a lot of, but it was a very rich and complete system at the time. But then once you got to a certain point, there weren't a lot of people involved, and it was built by a lot of professionals that were very expensive and had a lot of jobs and things to do. So you didn't really have access to their time. And it wasn't, it was a very well-built system, so it wasn't quite as hackable as Linux was, and the experts weren't cheap. Linux had all of these things. You could, since there was a larger user base, you could change the I to we so that you could sort of create a federation of the users. You could access the right people's times since they were mostly young and students. It was a more hackable system because it wasn't as complete, and so there are many places to do modifications, and it wasn't as hard to understand at first. And the experts were cheaper. There's a computer scientist, Calvin Morris, who spoke of this in 1959 in very 1959 computing terms. The more difficult and time-consuming it is for customers to use an information system or a computer or software, the less likely it is that they will use the information system. As the complexity of the problems become more intractable, the approachability of the lower levels internals of the system become increasingly important. This is also embodied in Zipf's law of least efforts. And so you need to have these details and these kinds of intrinsics, and you can't just have magical things happening at the top. This might be a good place to do that fucking graph. This might be a good place to put, so I've got this other chart, this hourglass chart. Hourglass, go here, question mark? So, we're going to talk about the prosumer software. Prosumer is a modern idea of a producer and a consumer put together. It is often used for social media where you're consuming other consumers' productions. And so Torvalds and hackers in general tend to create what Alan Perlis called the Turing tar pit in 1982. Everything is possible, but nothing of interest is easy. pulling yourself out of the Turing tar pit from a capable to usable system requires some engine to push it forward. And so we were able to do this in Linux with this problem solution integration. And so, for instance, if I had an NE2000, which was an early networking card, and I happened to create a driver for it, then I'd be able to put it to contribute it, and then everybody else who had an NE2000 could then use it. So that means that created the engine to push it upwards to mount ubiquity, so that new users had fewer problems on different hardware. But where do you find the people to do that? Well, you have to build armies. So, from toy to tool, value was created and the product fit better. By recruiting new troops, Linux was able to exploit something called Reed's Law. This is from 2001. The utility of large networks can scale exponentially with the size of the network. The number of combinatorial subgroup participants from these larger collections grow more rapidly than the original utility of the groups that joined. That's a word salad. So essentially, if I had an NE2000 and I decided, hey, me and my friend are going to go try Linux for the first time, but then I create a new group of me with all of the other NE2000 users where we can, work together, change the I to a we, in order then to create that engine and to move it forward and then get a driver so that we can all use networking. And that was possible. I don't think that that's what I need to do. All right. And that was possible because Linux started at the hobby, entertainment, and education level, and then went up to productivity, personal, and then business, professional, and critical infrastructure, bringing those people along as you went up there. I analyzed about 2.5 million Usenet posts over the course of about 2 years, and I looked at the domains of the email addresses that sent it, and you can see that, and I also analyzed BSD 386, that it looks like that 386 BSD had more commercial centers, and Linux had more edu centers for this time period, although their trends did map accordingly. And over time, the hobbyist, entertainment, education went down as the productivity, personal, business, and professional went up. You can call this the Linuxist revolutionary theory. Essentially, the hacker vanguard yields to the personal computer proletariat, which then gives way to the business-oriented bourgeoisie and the publicly assiduous aristocracy. But this isn't that cheap. As you can see over here, there is another form of price, so we have to look at the price of experts. So here is our final price. We're going to call it effort. It's an alpha times money, plus a beta times time, plus a gamma times expertise. And from that, we get to our utility, which is actually software capabilities divided by expert. Oh, my video is dead. Oh, it's okay. Fuck it. I don't need video. I think everything else is working fine. Let me see. Oh, yeah, just the video is dead. Let's continue. So, most software doesn't look like this. Sometimes both capabilities and efforts increase over time. Blender, for instance, is highly capable software, but also takes a lot of expertise to use effectively. Many mobile and web apps, on the other hand, actually remove power user features. I'm actually just taking off all my clothes right now since the video is gone. Over time, it makes the product require less effort while also making it less capable. So other software, APIs, and frameworks come to mind can have Fred Brooks' second smell effect, where they have a new version that's far more difficult to use and leads to inferior results. Thus being an inversion of the graph and decreasing the utility of the product. I'm going to remove that sentence. So let's talk about the multiple arrows. In order to get a larger user base, you need a diversity of capabilities requiring a diversity of efforts. Linux was able to achieve this by outsourcing the actual packaging of the OS through distributions. So, oh yes, write something about this. Use Apple as a vertical example. That should have been bold because I should have done that before I came back here. So Eric S. Raymond introduced something called the Cathedral and Bazaar as different ways of developing software. So the idea of the bazaar is everybody. I should probably go look it up so I paraphrase him right. Let's just pretend I do that well. And so yeah, I don't have anything more about this one, but I'll just wing it again. So essentially, Linux was able to develop itself horizontally as the use cases identify. So there's different people doing distribution, repository, organization, customization, and then the actual links, as opposed to, let's say, Apple, which is pure vertical, and they occupy every part of this. And so as a result, Linux can get more use cases out than Apple can. Anyway, so it resulted in something that I call the victorious anarchy. And so as you have different kinds of needs and different kinds of tiers of functionality, there are different strategies that a producer can apply. They can maybe go up market, or they can stay with customers, or whatever it is. But because we've separated out all of these things, we can then go all of these simultaneously. It's like a war where you have where you're being attacked from like 84 fronts at once, and that's why Linux won everything. Anyway, the packets, chapter 7. So we're gonna go with Andy Grove. Only paranoid survive. He talked about how the computer industry went from these vertical stacks like Apple has right now, and then over to these horizontal things in 1995. But however, this was a not survivable transition where you have all of these. What actually happened is that supporting everything became too expensive, and so Windows put the onus on the actual companies below in order to say, oh, you want this thing, you kind of have to write the drivers yourself and work with us. OS2 decided, well, we're just going to die, fuck that. Mac said, okay, we can go back vertical. And then Linux said, well, okay, we can do that as long as we get free labor. So, how can you get free labor? Well, there's something called the Eternal September. When the internet was mostly accessed at universities, September annually brought in a flood of new people that had to be coached. However, in the early 90s, as residential internet grew, the old guard termed 1993 as the Eternal September, the beginning of the mainstreaming of internet access. For this to happen, cheap ISPs and web servers needed to exist quickly to support users. And so you had to have ISPs cheaply, web servers cheaply, and then you have a networking effect that directly improves the quality of these top two things cheaply. And so another benefactor of the Eternal September is now attributed to something called Linus's Law. Given enough eyeballs, all bugs are shallow. And so let's look at various eyeballs. Here is Linus's early contributors. He released the code in October of 1981. His roommate was the first one to be a contributor. But then by the next month, Theodore So at MIT, across the pond, had a contribution. Galen Hunt from University of Utah, same month. Drew Eckhard had the bootloader. And then he went GNU in February. So that's 4 months. That's pretty freaking fast, actually. And happened organically. So in that same time period, you have all of these stats over here. And by the end of 1992, internet was doubling a 3-month click. And so a quick and dirty mutable solution was needed at that time. And so it turned out that you needed to have some cheap options. So here's some things that you could have possibly used in 1991, 1992. 386 BSD, sure, but it wasn't really cooperatively done. It was done by the Jolitzes and in the firm-based development. And so you couldn't have that engine that would take it away from the Turing Tar-Pit. NetBSD by 1983, sure, but here's our 2-year head start. Not through any BSD USL lawsuits, but because Linux beat it to the punch. So the earlier version, Net 2, really didn't do it, and it really wasn't a complete system. It didn't have all of the stuff needed. It is arguable that at 1981, Linux did not have networking support, but they got it in by 1992. And so it became one of basically the best fit at the time. That means over the past 30 years, Linux has become the only reasonable option. Here's a quote essentially from Linux saying that was the key time period. He said, I think the timing was good. Even just a year earlier, I don't think it could have been done. And a year later, somebody else would have done something similar, NetBSD. In our world, Windows basically says your move, it's your responsibility to do things. Mac says we'll do things vertically, and Linux says nom nom nom, we'll just eat it all up. So that's why you see Linux now on cars, phones, spaceships, toasters, everything. Here's a graph about supercomputing operating systems since 1995. As you can see now, Linux dominates over Unix. Here's web server operating systems since 2013. I don't know why Windows is still above 0, but somehow it is. Whatever. So let's go to the perhaps. Luck, a user's manual. What does the unlikely success of Linux tell us about how to feature? I'm sorry I just read a slide, but that's how it is. So let's go into Crossing the Chasm. This is Geoffrey Moore from 1991. Essentially, this is commercial software. I should probably write more about that. Control B, write shit here. And so essentially he's saying that in the early market, You have people that are innovators or early adopters, and these are the people that are like really sort of enthusiastic, or they have a dream, or they have a vision, and then you have this chasm before you get to what's called the pragmatic part over here. And actually, you know what? Swap out the graph. There's better versions of this graph with a better one. There's ones that actually explain all this stuff better. Complete solutions and not convenience. Yes, yes, yes. But there's ones that have done this one better. And so we can use electric cars for an example here. Essentially what happens is that we're in a chasm right now. You have pragmatists saying, yeah, but you know, charging takes too long and there's lines there and it doesn't go as far and blah, blah, blah. It's too expensive. Okay, fine. And so as a result, electric sales actually went down slightly. But if history is any guide, they'll eventually go pick up when those complaints are satiated. People have this with broadband. You can see this with cell phones, and basically any technology. This is the graph. Even with smartphones, this happened. So, but this is commercial software. What about open source software? I present crossing the open source chasm, and so this is more people-based and social history-based. Essentially, you have passionate people that really believe in something, and then they get enthusiasts that believe in what they are doing, what the core group is doing, or evangelists. And then that creates the engine to push things forward, hopefully until the pragmatists pick it up, and then the business people pick it up, and then eventually the enemies. And so in this case, now Microsoft is a big friend of Linux. And they have these stickers that say, like, I heart Linux. And that's why. So the problem is that reality is actually not like this. It's really messy. And so trying to map that out to in any kind of accurate, provable state, to my likings, is tough. And so how can we conclude? We really can't. Hopefully we choose stories with the strongest evidence and we do better than fiction. Hopefully, hopefully, hopefully. So the first one I'm going to present is vision plus failure. Does that equal success? And strong visions and not strong protection. So we have GNU herd led to Linux, which is something I should probably go a little bit over, or a little bit more. Minix. Let's just say Minix led to Linux. That's probably what I should do. Yes, let's just say Minix led to Linux. Yes. Ted Nelson's Xanadu, which is vaporware, led to the World Wide Web. Xerox Alto led to the modern desktop. And so these are strong visions for what could have been possible, but didn't actually work that well. So strong IP enforcement on strong visions diminishes its chance of success, and you must let go of that which you love the most. The next one is about the right pushy one. So if we go back to that graph beforehand, in fact, put the fucking graph here. Put the graph here again. The chasm graph. That would make it a lot. So essentially, for whatever you're working on right now, you are in that first. Let's just pretend it's there. Go up a bit. Let's just. You are in the passion group, so you're way early. You have not even reached this part over here, and you may not have this thing. So you are the dreamers of the dream, and you don't really have any music makers yet. So that you're definitionally way early, and aggression, as in your passion and your enthusiasm, is the key to success. And you also have to commit others because revolutions need armies, so you have to get all those other people on board. Really important. So the takeaway there is that it'll take years and manifest differently than you thought, and you have to love your ideas but avoid those codependencies. Really important. So next steps. Do one thing and do it well, work together, and handle text streams because that's a universal interface. That's actually Unix philosophy. It's partially a joke, but also partially real. We're going to use Tracy Goddard, Soul of New Machine, 1981. Looking into the VAX, West had imagined he saw diagrams of DEC's corporate organizations. He felt that VAX was too complicated. He did not like, for instance, the system by which various parts of the machines communicated with each other. There was too much protocol involved. He decided that VAX embodied flaws in DEC's corporate organization. The machine expresses that phenomenally successful company's cautious bureaucratic style. Also, Churchill basically said, we shape the buildings and thereafter they shape us. However, our buildings in software are different because the programmer, like the poet, works only slightly removed from pure thought stuff. He builds his castles in the air, from air, creating by exertion of the imagination. Or so says Fred Brooks. Regardless, wrecking balls for code are cheaper than those for concrete. So what we want to do is look at these rules and say, oh, you know what? That doesn't work. Just do that. Then that transition to, I like that one. I really like that. Let's just do a control I on there and B and see if I can make it work. I like that sentence, but we got to make it work. So essentially the idea is that these things work for software, but also work for humans because, we want to handle text streams as them communicate with each other. So there's another Unix philosophy. This is by Ritchie and Thompson. Make it easy to write, test, and run programs. Interactive use instead of batch processing with each other. Economy and elegance of design due to size constraints of our organizations. And create self-supporting systems. We can also go to Melvin Conway's 1967 law for this. Organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. Eric S. Raymond take out the S. Eric Raymond paraphrases this as, if you have 4 groups working a compiler, you'll get a 4-pass compiler. Perhaps we studied yesterday to create a better tomorrow. The future is ours to make. Probably. We're down to 45 minutes. All right, we're done.